Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
In previous session, Kirby talked about the overview of the Windows Azure. You have already seen that Windows Azure has many different components, different services, from the infrastructure service to platform as service. In my session, I will discuss the Windows Azure virtual machine. Actually, the virtual machine is a very fundamental, also very key service on Windows Azure. My name is Larry. My name is Larry Zhang. I'm Senior Program Manager in China Cloud Innovation Center, CCIC. Probably some of you already know that Microsoft has different kinds of solution offering for different scenario, from the private cloud to public cloud. Maybe you still remember that Kirby mentioned the ecosystem. There are three parts in that ecosystem. One is public cloud, the Windows Azure. Private cloud is mainly based on the Windows Server and System Center. Also, we have the service provider. So, no matter what kind of technology you want to use, actually, Microsoft provides some corresponding offering and solution. For example, from the physical machine to virtual machine to IaaS. Well, actually, here's a question for you guys. How many of you have used the virtual machine before? No matter what kind of, many of you guys, okay? So what kind of technology you use? VMware, Hyper-V, Citrix? Just make some noise. VMware, okay, good. Well, VMware is I would say it's pretty popular in private cloud, in hypervisor or virtualization, those areas. Today, we'll talk about the infrastructure as service. Infrastructure as service is not just the virtualization. Actually, virtualization is a very basic component in the infrastructure as service. When you have your own virtualization, you have to manage the physical machine and the virtual machine, everything about that. But if you use the infrastructure as service, you don't need to worry about the infrastructure. You don't need to worry about the networking, storage, computing. What you need to do is just provision of VM. That's what all you need to do. So when we talk about the cloud computing, maybe you are thinking about, well, cloud computing sounds is very high tech. Is there anything to do with me? Actually, cloud computing, from end user's perspective, is not like the it's not like the rocket science. It's as simple as 1, 2, 3. As you will see, on Windows Azure, as an end user, the first thing you need to do is just to pick up the way you will provision your VM, you create your VM. There's a couple of ways you can do. The first one is if you are a newcomer, if a newcomer on the Windows Azure, probably you will select the management portal. Because management portal has the better UI, is very user-friendly. From portal, you can provision a VM. If you are experienced user, let's say, you need to provision a VM or manage VM from time to time, probably you will use the scripting. You will use partial script or Node.js script. You can do some repeatable task job, that's scripting. Also, if you are a developer or you have developer in your organization and you heavily leverage on the Windows Azure to provide the resource, most likely you will develop your own solution based on the REST API provided by Windows Azure. There are 3 ways. Once you decide which approach you will use to provision VM, the step 2 is you select the image and the VM size. Well, there's 2 different kinds of image on the Windows Azure. One is Windows Server. The other is Linux, obviously. Then you select the size of VM from the H small to H large. Actually, we have the 3 additional, we call it the large memory scale. We'll talk about that later. It's from A5 to A7. after you select the VM image and VM size, you just click Create. Then Windows Azure will provision a VM for you. It just takes, let's say, a couple minutes, then you will have your VM running. The VM, the disk is running in the Windows Azure storage. It's a persistent disk. You don't need to worry about the data loss. Well, I will give you a quick demo on how to create a VM on Windows Azure. You will see how easy it is. Well, as you can see, this is a portal. This is a Windows Azure Management Portal. From this portal, I can see all the items on my subscription. If I want to create the VM, what I need to do is just click New, Compute, and select Virtual Machine. I use a quick create. I give it a name. Let's say IEEE Demo 1. I select image. Do you remember? We select different kinds of image. There's Windows image, there's a Linux image. Let's see, I pick up the old image. It's Windows Server 2008 R2 image. Then select size. From the extra small to A7. I use a small size. I give the administrator username here. And the password. Then I click create the VM. Then you will see from the status bar, you find that the VM is in the creating. Then after a couple of minutes, we come back, you will see the VM is running. Let's go back my deck. Well, as you can see, the create VM on Windows Azure is super easy. Just 1, 2, 3. That's it. As well, when I select a different image, you find there's a bunch of image over there. Windows Server, also some different kinds, different type of Linux image there. Right now on Windows Azure, we support some limited distribution of the Linux image. We support the SUSE, OpenSUSE. We support the CentOS, Ubuntu, also the Oracle Linux on the Windows Azure. Well, maybe you will ask this question. How about if I want to use an image? For example, I want to use the CentOS 6.4. That image is not available on Windows Azure. What I can do? Well, actually, you can bring your own Linux image. You can do that, no problem. But there's two things you need to take care of. One is you must install the integration component. That's actually it's the Windows Azure agent in your image. Well, you can get the Windows Azure agent from our website or from the open source community. Actually, the agent is open source. Itself is open source. The second thing is if you use your own image, we will not provide support for that image. That means if the image has some problem, you have to troubleshoot it by yourself. Otherwise, if you use the image in the gallery provided by our partner, actually you can get the support. For example, SUSE, if you use the SUSE image, Novell will provide the support. Different from the other Microsoft product, software or other service, Windows Azure is very open for the open source software. As you can see, actually on Windows Azure, the Linux I would say it's the first class member or first class family member on the Windows Azure. Right now on Windows Azure, we are more focused on the enterprise ISV. As you can see, most of the image from our partner. Actually, it's our partner responsibility to provide the image and support the image. Those images are more focused on enterprise. But we are also very open. We have to provide the image from the community, open source community. CentOS is the example. Actually, the CentOS is a very active community in China, also in the worldwide. So we also provide the CentOS image in our gallery. Support, as I mentioned, the image support is provided by our partner. For example, for the CentOS is provided by the OpenLogic. SUSE is provided by the Novell. After you pick up the right image, the things you need to think about is what kind of size, what size of the VM I want to use. Well, when you select different VM size, which means a couple of things. First, a different size of the VM means a different number of the cores you can use in that VM. The second one is a different size of the memory. Also, different size of VM means the different size of bandwidth. Well, actually, the bandwidth here is we only control the outbound bandwidth, not inbound bandwidth. That means if you have two VMs, well, VM1 is the extra large VM, VM2 is an extra small VM. But as you can see, extra large VM has 800 megabytes bandwidth. Extra small VM has, it's a bad example. Let's say VM2 is the small VM. A small VM has only 100 megabytes bandwidth. But if you transfer data from the VM1 to VM2, as you can have the bandwidth up to 800, because we only control the outbound bandwidth, not inbound. Besides the extra small to extra large, we have three very unique VM size. That's from the A5 to A7. A5 to A7, we call it large memory scale. Large memory means, as you can see, from the A5, we only have 2 cores, but it had 14 gigabyte memory. A7, 8 cores, but it has 56 gigabyte memory. Well, this kind of VM can be used on some of the memory incentive scenario. For example, database. As we all know, database will consume lots of memory. So in that case, you can use A5 or A7 VM size. Well, I just demoed how to create a VM. It's very simple. But you may have this question. What happened if I just, well, I need to provision 100 and say even the thousands of VMs? How can I manage those VMs? What happens if I need to do some load balancing or make sure the high availability of my VMs? How can I control them? Well, create VM is very simple, but if you have very complex deployment. For example, if you have project from NASA project, maybe you need the hundreds of VM. You have to think about the load balance and the availability. In that case, we provide some advanced feature you can leverage to manage your VM. The first one is cloud service. The cloud service is used to, you can organize your VM, you can group your VM in cloud service. What cloud service means, one cloud service we provide one public IP to that cloud service. If you group the VM in cloud service, that means those group of VM will share one public IP. Well, maybe you have a question, why I need to group those VM in the cloud service? The reason is in cloud service, we can provide some advanced feature, like the load balancer. You can have the multiple VM. You can do put them in one load balancer set. Let's say those VMs are all web server. They are in the same web behind the load balancer. You do the load balancer for those VMs. So those VMs must be in the cloud service. Also, if you want to make sure the high availability of the VMs, for example, you have 2 VMs, you want to make sure those VMs not in the one fault domain. Well, fault domain, basically, you can simply look the fault domain like the rack. Okay. We want to put the VM in a different rack. That means they are in a different physical machine. They are different in the use a different switch, use a different power supply. So in that way, if the one rack is going down, there's no impact on my business because my VM cross different rack. Okay. If you want to organize your VM in rack, in different rack or different fault domain, you have to use the cross service. In cross service, you can specify which domain and which domain they are in the one availability set. We'll talk about that later. Well, here is the example. In this example, we have the different tiers of the VMs. This is the front-end tier. We have 4 web servers. We put 4 web servers and 2 backend servers, these database servers. Those 6 servers in one cross service. In this one cross service, we have the 2. We can have the 2 availability sets. One is for the web server, one is for database server. Also, you can put the 4 web server behind the load balancer. That means the end user, they can access the one public IP through the HTTP or HTTPS endpoint. Then they can access the 4 instance by round robin. Also, we have this application may depends on some infrastructure. So we have another cross service. The cross service is used to provide the infrastructure for the whole deployment. The infrastructure including like the domain controller, DNS, or some other network service, infrastructure service. We put those infrastructure service in a separate cloud service. If you need to create the connection between your deployment on Azure and your own data center, actually you can create the VPN tunnel between the Windows Azure and your data center. This is a VPN. This is actually the IPsec VPN tunnel. So in that case, we can do the, let's say, the Active Directory replication between the Windows Azure and your own data center's domain controller. Do some replication between the. So in that case, actually, this virtual network is just pretty much like the remote office or one of your other subsidiary in your network. So it's a part of your network actually. So this is an example how we use cloud service load balancer to leverage those advanced features when we deploy or use the virtual network. We'll talk about the load balancer. Let's look at the availability. I just mentioned some of the concepts, like the fault domain, update domain. Well, if the first time for you to heard this term, you can just replace fault domain with the rack. It's pretty much like you can think it's a rack. Because when we put, you have the option. Well, when we talk about the availability, we have to talk about the SLA, service level agreement. On Windows Azure, we provide 99.95% of the SLA for the multiple instance. So what exactly means the multiple instance? The multiple instance is you have the multiple VMs. Those VMs, they perform the same function. You put those VMs in one availability set. If the availability set has more than 2 instances, whereas the Windows Azure can guarantee the 99.95% SLA for that service. Just in this case, we have 2 instances, 2 VMs in one availability set. As I mentioned, when you put the multiple instances in one availability set, the Windows Azure Fab Controller, they're very smart enough to know where place the VM in different rack. Okay. Well, those SLA means sorry. Let's go back. Well, that SLA means the data center level and the hardware level, the downtime is including in that the SLA. That means the 99.95% of the SLA means that we can only down the around 4 hours 1 year. Therefore, 4 hours including all the hardware failure, data center failure, also including the hardware upgrade, host operating system patching, those kind of stuff. So what's not included in the SLA, the VM level, the issue. For example, if your VM has its own self. For example, you delete some of the very important files, or you crash the VM. Those kind of the issue is not including in the STRA. Well, availability set is the for the VM we simplify the fault domain, update domain, those kind of concepts in the availability set. Availability set is you put the different same roles here. Internet Information Service web server. This web server 1, web server 2, they take the same role, they are the same functionality. So we group them in availability set. Or the SQL server, we have 2 database servers. They can mirroring, or they are used some other ones like the always on cluster. So you group those SQL server instances in availability set. So right now we have 2 availability sets. In that case, the web controller node, web controller is a management stack on Windows Azure. The web controller was smart enough to know we are put these 2 VMs in different fault domain. Just like put them in a different rack. The rack is fault domain in some case. Also, besides the fault domain, we also know we have put the different VM in the different update domain. Update domain means, because we use the VM is running on the physical machine. We need to patch in the physical machine. We need to replace some of the hardware components. So definitely the physical machine need to shut down for maintenance. So how we shut down the physical machine but has no impact on your virtual machine? The way is we organize the VM in the availability set and also in the update domain. In that case, this VM, web server 1, web server 2, they are in the same availability set. They will be in the different update domain, which means we will not update these 2 servers at the same time. We are arrange different schedule for the different maintenance for those VMs host. That's availability set means they are put in a different fault domain and different update domain. Let's look at the example of how we design the very complex deployment on the Windows Azure. You have the 2 web server. You have 2 SQL server. They are leverage the SQL mirroring to provide a high availability. In that case, we are organize the SQL server in one availability set. That's the SQL-AV set. We are organize the 2 web server in a separate availability set. That's the RS-AV set. We are also put the 2 web server behind the load balancer. So in that case, the user will access the public IP on the load balancer and then redirect to the different instance. Well, let me do a quick demo on how to use the load balancing and the high availability. Well, we can first look at the VM we just create. This is IEEE Demo 1 VM. It's the Windows Server 2008 R2 VM. After the VM create, you will have the notification here. It says successfully create the VM IEEE Demo 1. Here's detail, and just click OK. I skip the notification. Then I can click the VM. You will have the first dashboard view, give you a summary of the VM, like which IP is used, which the public IP and which the private IP. Also the some of the performance data, like the hard disk performance, memory, CPU, networking. All those infrastructure metrics here. Also, you can see this is a host name. This is a DNS name. That means the VM is running on Windows Azure. You can access the VM from the internet. You just use this DNS name. You can access it. this VM has the public virtual IP. Well, internally, it uses the internal IP. It's a private IP. Okay. That's the IP you will see from the VM itself. But this IP, public IP, is your end user. Your user uses the IP to access the service. Okay. As the administrator, now I can click connect. Actually, connect will open the RDP remote desktop connection file. Well, I cannot move my mouse. Okay. Okay. Click open. Click connect. Now I just need to input my username and password. The username and password is one I set when I create the VM. Maybe you still remember. What's the name? What's the username? Do you remember? Larry ZH. Okay. 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 Password. I never tell you a password. Okay. Okay. Well, this is a VM that's running on Windows Azure. Actually, you can also provision the Linux VM. Well, you have to use like Telnet or the tools to connect to the VM through the 22 port. When I create this VM, maybe you will see. Actually, I didn't configure any cloud service. I didn't configure the load balancer or the availability set. The reason is actually there are two wizards help you create VM. One is a quick create. Quick create means you skip lots of settings. Just use it by default settings. By default, if you use the quick create, it will create a separate cloud service for the VM. Here's cloud service. As you can see, there's two cloud services. One is IEEE Demo 01, Demo 1. This is the cloud service which is when we create VM, they create the cloud service for that VM. The other cloud service is called Zhang. It's my last name. If you look at the VM, this VM, this cloud service, actually the service has multiple instances here. It has two instances. One is called Windows Server 2008 R2. One is called Windows Server 2012 R2, two instances. So I grouped those two VMs in one cloud service. Then I can, as I mentioned, in this case, we can use the load balancer. We can use we can configure the availability set for these two VMs. Let's first look at the load balancer. Okay. Right now, if I click the 2008 R2, there's a page called Endpoint. Endpoint means it's pretty much like firewall. Okay, you create a VM on the Windows Azure. By default, the VM can only open a very limited port on the firewall on our load balancer. Well, let's look at the nuclear VM. That's the IEEE demo. If you look at the endpoint here, you have only two endpoints open. One is for the PowerShell. The other is for the remote desktop. Both of the two endpoints are only used for the remote management. What happens if I use actually the IEEE demo? Maybe it's a web server. So what do you need to do? It's a web server. Can I access the web server from internet right now? No, of course not. Why? I don't have endpoint here, so I need to do is I add a new endpoint. Okay, I create the standalone endpoint. I say protocol is the TCP protocol. Sorry, wait. And name here, maybe, well, I just use the default name. It's HTTP. The public port is 80. The private port is 80. That means I will open the TCP 80 port on the firewall. So after I create the endpoint, the user can access the IEEE demo 1 from the internet through the HTTP protocol. I skipped this part. Let's go back to the let's go back to the here. I have two instances here. One is 2000 AR2. This one has 3 endpoints. One is HTTP, and it's not just a standalone edge. It's not just a simple endpoint. Actually, this is a load balancer. I create a load balancer. The load balancer will listen on the TCP port 80. Right now, if I look at the other instance, this instance has only the default endpoint. There's no load balancer or HTTP port there, endpoint there. So this is my DNS name, right? It's john.cloudapp.net. I refresh this one. I got the page. The page is the default page of the Windows Server 2000 AR2, because Windows Server 2000 AR2 is the RIS 7. Now, what I will do right now is I will create that new endpoint on the Windows Server 2012 R2. Create new endpoint here. I will join this instance to the load balancer. Let's see how can we do this. I select this option, add endpoint to an existing load balancer set. I have a load balancer set. It's a Larry ARB1. Then I give it name, HTTP, let's see, ARB1. I don't need to reconfigure the load balancer set. I just use the original setting. Okay. Click OK. Complete. Then you will see we have the new endpoint here. This endpoint is also part of the load balancer set. After the update complete, we will refresh this page. You will see sometimes you redirect to the RIS 7 page. Sometimes you will redirect me to the Windows Server 2012 R2 Internet Information Server page. That's RIS 9 or 10. I don't remember the exact version. Well, it takes just 1 or 2 minutes. Again, here's the status bar. You can see what's happening right now. It's complete or it's failed. Okay, it's done. It successfully added endpoint to my new instance. Now let me refresh the second page. As you can see, it's a round robin. So when I refresh the page, it redirects me to the new page. This new instance uses the Windows Server 2012 R2. So this is the new home page. Okay. That's the load balancer. Let's look at the availability set. On each VM, you can see, well, you can configure the availability set. You can use the existing availability set, or you can create a new availability set. For example, right now I have just two instances in this cloud service. These two instances are both web server, so I created a availability set for them. In the previous example, we had 4 VMs, 2 web server, 2 database server. So in that case, I can create the new availability set for the database layer, database tier. So in that case, we have 1 cloud service, 2 availability set. Okay, let's go back to the cloud service. You will see when I put the 2 instances in the same cloud, seeing the availability set. So you will find those 2 instances will be put in the different update domain and the different and different fault domain. See here. So it's good. We are in the different. We in the different update domain. We suppose should be in the different fault domain either. I'm not sure. Maybe I just change the configuration. Let's go back to this one and config. Maybe I just create the VM this morning. It may take some time to move to the different fault domain. So you can see we can leverage the load balancer and the availability set to manage the high availability and manage the performance load balancer. So if you create a new VM, you can use the quick create. You can use provision from the gallery. If you provision from the gallery, you have the many advanced settings. You could have the more choice, like which cloud service you want to join, which availability set you will use. From here, you can select the different image, including the image introduction here. For example, right now I can create a new, let's say, CentOS image. OpenLogic, CentOS 6.3. Okay, next. I give the name. IEEE Demo 2. Also, it's a small one. You can select upload the SSH key, or you can create a create a password. I use password. Then I create next. Well, this page I have the more choice here. I can select join the different cloud service. I can select join the IEEE Demo 1 cloud service. Because I joined this cloud service, so it will put me in the. Well, I can also select the different storage count I want to use. Well, my colleague, we will talk about the storage later, so I skip this part. You can see we can create a availability set here. We call it IEEE availability set. Do I go next? You can create the different endpoint here, or you can just leave here. It's by default only open the 22 TCP port for the management, for the remote manager. Okay, create. So after this VM create, you will see IEEE Demo 1 the cloud service will have the multiple instance here. Only one, but when this create complete, you will have the 2 instances here. You can configure the load balancer, you can configure the availability set, those advanced features here. That's what I want to demo, the load balancer and the availability set. Let's go back to my deck. Okay. After your VM create, you must deal with some of the resources in the VM. When you create a VM, by default, it will give the 2 disks. One, you have the actually you have default configuration. You have 2 disks. One is OS disk. No matter if you Windows Server OS or Linux OS, you will have the OS disk. Operating system is installed on this disk. Well, actually, it depends on the operating system. If you use Windows Server operating system, you get the 100 27 gigabyte OS disk. If you use the Linux operating system, you got the 30 gigabyte disk. Well, what in case if you need the more OS disk space, what you can do? Well, you can create your own image. You can create your image. You can use the Hyper-V to create your own Linux image, and you upload the image to the Windows Azure. You can provision VM from your own image. Okay. Well, it's automatic. Well, the second disk is the temporary storage. Just like the name tells us, it's the temporary storage. It's not persistent storage. Well, actually, this storage is the disk in the host machine, not in the Azure storage. That means if your VM move from the one host machine to another host machine, the content in that disk will lost. So it's not persistent disk. It's just for the temporary use. But that disk might have some benefits for you. The first benefit is about disk latency. Well, OS disk and other disks are all still in the remote storage. So when you access those disks might provide the better IOPS, I/O per second, but the disk latency might be your concern. For example, the disk running in the Windows Azure storage, you access disk data from the VM to that disk. The disk latency may be, well, in some cases, maybe more than 20 milliseconds. So for some application, it's okay. But for some other application, that might be a concern. So in that case, you can leverage the local disk to save some of the data which need the low disk latency. You can use the temporary disk. Well, again, the temporary disk is not for the persistent data, so it's only for temporary use. We have the, besides the OS disk and temporary disk, we have the third type. It's a data disk. The data disk, you can have the multiple data disk. If you remember, when I talked about the different size of the VM, I mentioned the different size of VM means the different cores and different memory. There's also one thing is different. It's the number of the data disk can be attached to the VM. For example, if you have the extra large VM, you can attach up to the 16 data disk. If you use the extra small, you use a small VM, you can only attach the one data disk. So it's different. Also, for the data disk, it can up to the 1 terabyte for the storage. In addition, for each the data disk, we can give you the 500 IOPS performance. So, well, let's do a very simple calculation. So, what in case you need the, let's say the 9,000 IOPS, how many disks you need to attach the VM? 16. So you need extra large VM to attach 16 data disks to provide you 9,000 IOPS. Well, OS disk and data disk, they have the cache setting. Cache setting, they have the default value. For example, OS disk, the cache is enabled by default. But for data disk, you can control you enable cache or not. Well, in most cases, or based on our experience, based on your experience, maybe you will say, well, definitely I should enable cache. But this might be not true on Azure. The reason is, the cache on Azure, the cache on the disk actually means two things. One is some of the cache is in the memory. Well, that speed is very fast. It's very it can improve your performance. But some of the cache on the local disk of the host machine. So let's say in some cases you need cache loss of data. The data is larger than the memory cache. So you have to leverage the local disk on the host machine. As we all know, the local disk on the host machine cannot provide the same IOPS level as Windows Azure storage. So in that case, you enable cache cannot improve your performance. Not just cannot improve, actually it even can be worse. So our suggestion is if you only a small data, let's say very small database, you can enable cache. But you have very large database, let's say more than 10 gigabyte database, do not enable cache. Okay, this is I would say this is the best practice sharing. Of course, you can also try to enable, disable, and test the performance, then get the best configuration for your scenario, for your case. Okay. That's the cache. The cache, we'll talk about that cache setting. Besides the temporary data, temporary disk, the OS disk and data disk are all stored in the Windows Azure storage. The Windows Azure storage is the persistent storage. Actually, we have the 3 core base in the Windows Azure storage. So from the Windows Azure running from the first day Windows Azure running to today, we never lost any data, never. So this is very reliable. As you probably know, we have the 3 core base for the data. Actually, durability is more than 11 nines. Besides the local 3 copy, you can even have the option to enable the we call the geography replication. That means you will have another 3 copies in the remote data center. Gerbie mentioned when we built data center, we group data center in different regions. For example, in the Asia, we have 2 data centers. In Singapore, in Hong Kong. Singapore and Hong Kong data center, we say they are in the same region. So these 2 data centers, they will do the geo-replication for each other. So if you enable the geo-replication on your storage count, you will have 6 core in total. 3 in local data center, 3 in remote data center. We will make sure that those 2 data centers is far away from each other, more than 500 miles. So just in case the VM is, the host machine running VM is going down, we'll start a new instance from another host machine. The host machine will pick up the data in the storage, Windows Azure storage, and continue running the VM for you. Okay. We have talked about the disk. Then let's have a look at the image. As I mentioned, actually we provided a bunch of image. You can also create your own image by yourself. For example, you have different ways to create an image. The first way is you can set up Hyper-V in your environment, in your data center. Then you can install the Linux or Windows Server on the Hyper-V. Then you do sysprepare, or you do the Windows Azure deprovision, running those agents. Then you save the VHD and upload VHD to the Windows Azure. Then you can provision the VM based on those images. The second approach, that approach is you create a VM from based on our official image. Then you customize your image. Customize your VM. Then you capture the VM as your image. There's 2 approaches. Well, this is the first way. You create your own image from your data center. You upload to the cloud, upload to Windows Azure storage. Then you can create the VM from that image. That's uploading. Create the VM. That's one thing you need to take care of. If you upload the image to the one storage count, you can only provision the VM in that storage count. You cannot select the storage count. Do you remember just now I created the VM? I created a second VM, the IEEE Demo 2. I have the option to select which storage count I will put the VM in. But if you provision VM from your own image, you cannot select the storage count. That means if you want to place the VM in different storage counts, you have to upload different image in different storage count. It's the first way I bring your image. The second way is you create the image from the cloud. That's you already had the VM. You provision the VM from the official image in the gallery. Then you put the VM. You customize the VM, and you do some the generalized, like sysprepare or Windows Azure deprovision. Then you capture the VM. After you capture VM, the VM will receive in the storage count. Later you can provision the VM based on that image. Well, I will show you how to capture the VM. Well, I have two VMs here, and let's see. I have the let's see. I have do some the customization work on the demo 2. So for demo 2, you will see I have the option here is the capture. Well, I need first to shut. Suppose I have to do some the deprovision job here. I shut down the VM. After I shut down the VM, the capture button will not grey out anymore. So I can use the capture to capture the VM as image. Besides the capture, stop, you have other options like like the restart, and you can also attach disk. Attach disk means you attach the disk to the VM. You can attach multiple disks. It depends on the size of the VM. You can also change the size of VM. But anytime you change the size of VM, it needs to restart the VM. Okay. For example, for this VM. We use the small size. Actually, we can change to the, let's say, A7, 56 GB memory size, the VM. Then I click the save. After click save, it will restart. Then the VM will be the super large VM. I'll skip this part. Okay, it's been shut down. Then let's look at the VM. Well, you can see we can capture the VM as an image. I give the name for the image. Let's say IEEE image. I have to run the Windows Azure agent deprovision command. Actually, I didn't, but I just work around here. So after the capture the image, you will have your own image. Right. Okay, let's go back to my deck. Last, let's talk about how to manage the VM. Let's create a VM now. Oops. We have how to manage a VM. Well, actually, manage VM is pretty simple. It's just like you manage your virtual machine in your data center, or like manage your physical machine in your data center. You can leverage all the management tools you are using today. For example, if you want to do some of the monitoring, you can do the patching. All the solutions can also be applied on Windows Azure. What you need to do is you either deploy the management system on Windows Azure, so you can manage those other VMs. You can also have the option to use your management server in your data center and create a VPN tunnel between the Azure Virtual Network and your data center. In that way, you can leverage the existing management servers to manage those VMs. As for the Windows Azure VM itself, it can be managed by the script. On Windows, the script can be used on the Windows client, Mac, or Linux client. We support the PowerShell on Windows Server, Node.js, client command line interface on Linux. Well, actually, the script is pretty powerful. It can do almost everything you do from the portal. Well, that's pretty much all. In my session, we talk about the experience, how we use the VM, how to create VM, how to manage the load balancer, availability set. We also talk about how to create disk image and how to manage the VM. So yeah, that's my session. Next, I will pass time to my colleague Sun Wei. He will talk about the Windows Azure storage and the SQL database. Yeah. Before that, let's take the 5 minutes short break. Thank you.